Hello बच्चों, let us see this matching type question. Match the column 1 with column 2. Column 1 में दिया है complexes ABCD. हमें मैच करना है PQRS में जो properties के बारे में, mu के बारे में, optical activity, inner orbital complex और outer orbital complex, ये हमें बताना है. Okay, let us solve this question. The first one is A, CR, CN3, NO2 taken thrice and minus 4 or 4 minus. Here central metal atom is chromium, right? What is chromium oxidation state? X plus 3 into minus 1 plus 3 into NO2 का we charge minus 1 है is equal to minus 4. So X minus 6 is equal to minus 4. X is equal to plus 2. So chromium का oxidation state यहाँ +2 होता है. So let us see this chromium electronic configuration. Chromium electronic configuration is argon 4s1 3d5. It has stable half-filled electronic configuration. But in Cr plus 2 means 2 electrons are lost. 2 electrons कहाँ से चले गए? Outermost एक और यहाँ 3d में से एक. So it has 3d4 4s0 4p0 4d0. This is the electronic configuration outermost shell. And here 3d4. This is 1 2 3 and 4. Here coordination number, here 3 plus 3, there are 6 dative bonds are formed by this, and coordination number is 6. So coordination number 6 means it is an octahedral complex, and octahedral complexes either undergo sp3d2 hybridization or d2 sp3 hybridization depending on the ligand, right? So as the Cn minus is a strong ligand, pairing takes place again as the Hund's rule. Cn minus is a strong ligand. Pairing of electrons takes place again as this Hund's rule. So actually, how many d orbitals it requires? S orbitals, p orbitals 3, and in outermost d orbitals also available, right? So as ligand is strong, this electron is paired up with the first one. Only one electron is going to pair here because it requires only 2 d orbitals for hybridization, d2 sp3 hybridization. So 6 ligands are coming, so 6 orbitals are required. So first one only pairing up. Second and third electron is here. These two are unpaired electrons. Unpaired electrons are 2. So n value is equal to 2. So if you observe this mu is equal to square root of n into n plus 2 Bohr magnetons. Here n value is 2. 2 is the number of unpaired electron. So substitute. So mu is equal to root of 2 into 2 plus 2. So 2 into 2 plus 2, root 8, and root 8 can be written as 2 root 2 Bohr magnetons. So it is matching with point R, and as it is d2 sp3 hybridization, inner d orbital is involved in the hybridization. So it is inner orbital complex. So it is matching with Q, inner orbital complex. It is matching with Q and matching with R. So A option is matching with Q and R. Okay. Now let us see this option. Option B देखेंगे. Option A का आंसर तो हमें आ गया. A is Q and R match हो रहा है. So next let us see option B. So option B में दिया है cobalt complex CO C2O4 oxalato ligand, and it is a bidentate ligand, and this is the complex given in this. So a cobalt central metal atom and its oxidation state X plus 3 into oxalato C2O4 minus 2. So minus 2 is the oxidation state, and that is equal to minus 3, which is the charge on the complex. X minus 6 is equal to minus 3, and X is equal to +3. So cobalt is in +3 oxidation state. And next one here, this is a bidentate ligand and each one forming 2 coordinate covalent bonds. Total coordinate covalent bonds are 6. As it is coordination number 6, it is an octahedral complex. So octahedral complex means either it undergo sp3d2 or d2sp3 depending on the availability of the orbitals. Okay, let us check. Cobalt atomic number is 27. So argon 4s2 3d7. This is its configuration. But cobalt is in the +3 oxidation state. So 3 electrons are lost. 2 from 4s and 1 from 3d. So it becomes 3d6 and 4s 0, 4p 0. So okay, this is outermost. And this is d with the 6 electrons and s orbital and p orbitals are vacant. Now this electron fillings 1, 2, 3, 4, 5 and 6. So what will happen? It requires 2 d orbitals for sp3d2 or d2sp3 hybridization, but here the ligand is oxalato. Because of this, what will happen? Pairing of electrons takes place. So this is paired with this and this is paired with this. As pairing takes place, what will happen in the next case? So this is 1, 2, 1, 2 and 1. This is d orbitals are available for d2sp3 hybridization here. So d2sp3 hybridization means inner orbital complex. Inner orbital complex is matching with the Q. And next one, is there any unpaired electron here? No, there is no unpaired electron. So R mu value 0 रहता है. So R तो match नहीं होता. And C2O4 minus 2 is a bidentate ligand. And bidentate ligand containing complex compounds, generally they exhibit optical isomerism. So it shows optical. This complex shows optical activity because of this bidentate ligand oxalato. Even EN, ethylene diamine, containing complexes also exhibits optical isomerism and shows optical activity. So it is matching with the Q and S. So B option is matching with Q and next we'll see the C option. In C option, what we have? Fe. EDTA complex minus EDTA is a hexadentate ligand. It's a single one can form 6 coordinate covalent bond. So coordination number of this complex is 6. And let us find the oxidation state of iron. Here iron oxidation state X plus EDTA, it's a ethylene diamine tetraacetate ion. So acetate ion, so 4 acetate ion, so 4 minus will be there in this EDTA and that is equal to -1. So X is equal to +3. So iron is in the +3 oxidation state in this complex. So iron atomic number is 26, argon 4s2 3d6. This is in iron, but iron is in P +3 oxidation state. So it lost how many electron? 3 electron. 2 from outermost and 1 from 3D. So it has argon and 3D5, 4s0, 4p0, okay, 4d0. This type of configurations it has. So then what will happen if d orbital representation? D orbitals are 5 electron. 1, 2, 3, 4 and 5. Okay, and here this s orbital and these are p orbital. So how many? See, the coordination number 6 means it is an octahedral complex. For octahedral complexes, either sp3d2 hybridization or d2sp3, d2sp3 or sp3d2. So here inner d orbitals it requires 2. So what will happen? Pairing takes place because of this EDTA ligand. So pairing takes place. After pairing takes place, how many vacant d orbitals are available for hybridization? This is one pair and this is second pair. So one more electron is left, and these two d orbitals are available for hybridization. ये d orbitals दो, ये s orbital and p orbital तीन मिलकर d2sp3 hybridization में involve होते हैं, and after that it is bonding with the EDTA complex. d2sp3 hybridization. As inner d orbital is involved in the hybridization, it is called inner orbital complex. So inner orbital complex हमें q point में है, so ये match होता है q से. Inner orbital complex, that is q point. And next one is as EDTA, so it's a polydentate ligand. I already explained you that optical activity is exhibited by the polydentate ligand, like bidentate ligand. So here it can also show optical activity. So its C point is matching with the Q and also yes. And lastly, we have to see this D option. In D option, what is given? In option D, it is given nickel complex Ni, En3, NO3 taken twice. Okay, this is the complex given. So here En is a bidentate ligand. En means ethylene diamine and our ethane 1,2-diamine. It is a bidentate ligand. Means each En can form two bonds. Each En can form two bonds. So there are three Ens. 3 twos are 6. So 6 coordinate covalent bonds are forming. So coordination number is equal to 6 and it forms an octahedral complex. So as it is an octahedral complex, it must exhibit either sp3d2 hybridization or d2sp3 hybridization. So nickel oxidation state in this complex, that is X plus 3 into 0, because ethylene diamine is a neutral ligand, plus this 2 into minus 1, NO3 is minus 1, so 0. X minus 2 is equal to 0, X is equal to plus 2. So nickel is in the plus 2 oxidation state in this complex. So nickel atomic number is 28, so its configuration is argon 4s2 3d8. So 2 electrons are lost from the outermost shell. So now it is in the Ni plus 2. It is showing argon 3d8 configuration only and 4s0, 4p0. Now this d orbitals having with 8 electrons. This is 1, 2, 3, 4, 5, 6, 7 and 8. So it should form 6 bonds. It means it requires 2 d orbitals for this. Even if it is pairing with this, it is not, we are not able to get 2 vacant d orbitals for d2sp3 hybridization. Here d2sp3 hybridization is not possible because even after pairing this electron, there is only one d orbital is vacant, but we require 2 d orbitals vacant. So inner orbitals are not involved in the hybridization, so that outer d orbital is participating. So 4 d orbital is participating now. Yes, p orbitals 3, d orbitals 2 undergoes sp3d2 hybridization, and outermost d orbitals are involved in the hybridization, so on bonding also. So we can say that it is a outer orbital complex. So outer orbital complex is matching with the p point, right? Outer orbital complex is a p point. It is matching with the d option. And next one is how many unpaired electrons are there? Observe here we have 2 unpaired electrons. Unpaired electrons 2. So magnetic moment mu is equal to square root of n into n plus 2 Bohr magnetons. Bohr magnetons are the units of magnetic moment. So root over 2 into 2 plus 2, that is equal to root 8. Root 8 can be represented as 2 root 2 Bohr magnetons. So this is matching with the R point. And En is a bidentate ligand. As En is a bidentate ligand, it can show optical isomerism. This complex shows optical isomerism. So it is matching with the yes point also. So what are this? Option D is matching with the P and R and S. So all options I explained. Hope you understood. Good luck.